Hey guys, Mrs. Dan's here. Today we will be learning some new math skills. Okay, I'm just kidding. It's Amber. Make sure you go follow me on TikTok at amber_dance.209. Me and my mom are working on the Renegade dance. She's trying really hard to get it. You know, it might take a while though. So you make sure you go check that out when it comes out. And here's my mom. Have fun learning math.
Hey guys, so really it's Mrs. Dan's, and that Renegade Dance, I don't know. I don't think it's coming along very well. But I would like to work on quadratic equations with you since you have a test on Monday. So I will be going through the review questions that I assigned to you, and number 1 and number 2 actually ask you to do the same thing. So number 1 is asking for the solution set to the following quadratic equation, where number 2 is asking for the larger root of the equation. Really the same thing, where number 1 I'll be giving 2 answers, and number 2, out of the 2 answers I'll be giving the larger one. So we learned that we can solve quadratic equations algebraically by factoring. So the x squared minus 2x minus 5 does not have a GCF, therefore it factors into the product of two binomials. The two things that multiply to be x squared minus 2x minus 15 would be something whose first terms in each binomial is an x, because x times x is an x squared. And the last terms have to multiply to be a negative 15. So maybe it'll be a positive 1 and a negative 15. Maybe it will be a negative 3 and a positive 5. Maybe it'll be the opposite signs. Maybe it'll be a negative 1 and a positive 15, or a positive 3 and a negative 5. And to get my outers and inners to be a negative 2, I can see that I should use a negative 5 and a positive 3. Negative 5 and positive 3 multiply to be negative 15. When I check my outers, I get a 3x. When I check my inners, I get a negative 5x. And this adds to be a negative 2x. So it factors properly. Now I'll set each factor equal to 0. X minus 5 might equal 0, while x plus 3 might equal 0. If I add 5 to both sides, x equals 5. If I subtract 3 from both sides, x equals negative 3. So my roots are a negative 3, a positive 3, and a positive 5, and a negative 3. Positive 5, negative 3, choice 2. On number 2, it's already factored, so all I have to do is set each factor equal to 0. Maybe x plus 4 equals 0. Or maybe x minus 3 equals 0. So when I subtract 4 from each side, x equals a negative 4. If I add 3 to each side, x equals a positive 3. They ask for the larger one. Of course, the positive is larger than the negative, so the answer is choice 3. Next page. So which equation could represent the relationship between the x and the y values shown in the accompanying table? Yeah, I can notice that choice 1 is linear, choice 2 is quadratic, choice 3 is quadratic, and choice 4 is exponential. We've learned about all these kinds of functions. I could look at the rate of change to see if it's constant. This is going up 1, while the x is going up 1. Therefore, the first rate of change is 1 over 1. The next rate of change, this is going up 3, while this is going up 1. So that's a 3 over 1, which means it's not linear because it's not a constant rate of change. We could, if we wanted to, enter these things into our graphing calculator. Like if I enter choice 2 into the graphing calculator, in place of y equals, I could put choice 2, which says x squared plus 2, and take a look at the table of values. At 0, it's a 2. At 1, it's a 3. At 2, it's a 6. At 3, it's 11. At 4, it's 18. I'm done. I'm not going to do any more work. I know it's choice 2. So make sure you're using those graphing calculators to your advantage. Number 4, we have to factor completely. The very first thing we look for is a GCF. I see a 2 in common. I'm left with a squared plus 3a plus 9. And then we look to see if it's factorable again. It might be, it might not be. If it's factorable again, it means that this C term of 9 might be able to give me outers and inners. That's a 3a. And is that possible? A 1 and a 9 and a 3 and a 3. And the answer is no, it's not possible, so we're done. Letter B, there's a 5 in common. I'm left with a squared minus 1. And what I notice about a squared minus 1 is that it's a difference of 2 squares. I can do a plus 1 and a minus x minus 1, and leave that GCF of 5 out in front. Letter C, I see that there's an n in common, so I'll be left with 4 minus n squared. Some don't notice this, but this is a difference of 2 squares as well, because 4 is perfect. 2 times 2 gives me 4. N squared is perfect because n times n gives me n. So this 4 can be written as 2 times 2, while this negative n can be written as a negative n and a positive n. This is the completely factored form of 4n minus 3n cubed. Number 3, there isn't a GCF, so I'm hoping I can factor it into the product of 2 binomials. 3d squared, I'm thinking about a 3d and a d. A negative 10, I have some choices. It might be a negative 1 and a positive 10, or a positive 1 and a negative 10. It also might be a negative 2 and a positive 5, or a positive 2 and a negative 5. I'm going to try a 2 and a 5. I'm going to try a positive 2 with the d and a negative 5 with the 3d. I told you that with practice, you'll be able to get your answer quicker. I see that 3d times 2 is a 6d, and that a negative 5 times d is a negative 5d, which of course combines to be a 1d, which is exactly what it says. So I just factored it with only this one try, only because I've been practicing this for so long that I'm able to kind of like look in advance and figure out my factors pretty quickly. And one day you'll be able to do it just as quick. Letter E, I see that there's a GCF of 3. If I take out the 3, I'd be left with a t squared plus 6t minus 36. I actually should have taken out 3t. So I'm changing some of my answers now. If I take out a 3t, then I'd be left with a t plus 6 minus 16. And this plus 6 and this minus 16 are like terms. So I have a 3t times a t minus 10. And that's my final answer. I am doing this for the first time right here in front of you. So I'm happy to kind of like maybe make a mistake, notice my mistake, and fix it, because maybe you can learn from it as well. When we solve these equations, I like it set equal to 0, so I'll subtract 16 from both sides. I see a GCF of 4. That's my dog, Cammie. We are getting pizza delivered today for lunch. And a squared minus 4 is a difference of 2 squares, so I have an a plus 2 times an a minus 2. And I can set each factor equal to 0. To be honest with you, there are 3 factors here. There's a 4, there's an a plus 2, and there's an a minus 2. Does 4 equal 0? The answer is no, so this one gets rejected. Maybe the a plus 2 equals 0, or maybe the a minus 2 equals 0. So if I subtract 2 from both sides, a is a negative 2. If I add 2 to both sides, a is a positive 2. So my 2 answers are a negative 2 and a positive 2. In B, there's a GCF of 3b. I'm left with a b minus 3, and I'm done factoring. But there are 2 factors. Maybe 3b equals 0, or maybe b minus 3 equals 0. If I solve for b over here, I'll divide both sides, and b equals 0. On the right set of factors, I'll add 3, so b equals 3. So my solutions are 0 and 3. In C, it is quadratic because of the x squared, so I'm going to get it set equal to 0. I'll say that 3x squared minus 16x minus 12 equals 0. First, I look for GCF, and I see if there's anything that divides into all 3 of these terms, and there isn't. So I have to decide that it's a trinomial that can hopefully be factored into the product of 2 binomials. 3x squared can be separated into a 3x and an x. A negative 12, I have a few choices. Maybe it's a negative 1 and a 12. Maybe it's a negative 2 and a 6. Maybe it's a negative 3 and a 4. Or maybe those signs are opposites. How about we try... How about we try like a positive 6 and a negative 2. If I check my outers, I get an 18x. If I check my inners, I get a negative 2x. This turns out to be a 16x. And what I can say is, oh, so close, but not perfect. I have the right number, but the wrong sign. So this isn't right, but it is really close. I'm going to keep the 3x and the x. I'm going to keep the 2 and the 6, but I'm going to make this a plus 2 and this a minus 6. And now when I check my outers, I get a negative 18x. When I check my inners, I get a positive 2x. This gives me a negative 16x, which is exactly what I needed. So now I'll set each factor equal to 0. And when I solve this first one, I'll subtract the 2 and then divide by 3. So x equals negative 2/3. In the second one, I have to add 6 to both sides. so x equals 6. There are two answers of negative 2/3 and a positive 6. Next page. Number 6, it's just asking me to factor. There is not a GCF. It is a trinomial, so I guess it can factor into the product of two binomials. And at the start, I have to do a 2D and a D. And then for this 7, it has to be 1 and a 7. I just have to decide where does the 1 go and where does the 7 go. I think the 7 goes in the first set of parentheses while the 1 goes in a second set. Since it multiplies to be positive but adds to be negative, I think these are both negative because negative times a negative is positive, but when I add them I get a negative. If I check my outers, I get a negative 2D. When I check my inners, I get a negative 7D. These combine to be a negative 9D, which is exactly what it says. I found my answer. I'm done. I cannot go any further because it was an expression. The only thing I can do is factor it. But in B, it's the same like trinomial, but it has an equal sign and a 0. So now I know that it already factors to be 2D minus 7 and D minus 1, but it equals 0. Therefore, I can solve it by setting each factor equal to 0. So equations can be solved, but expressions can't be. Expressions can be simplified. Expressions can be simplified. Or factored, sorry. So on this first one, I can add 7 to both sides. So 2D equals 7. And divide by 2. Therefore, D equals 7 over 2. On that second factor, if I add 1 to both sides, D equals 1. So now I can solve it. I say the answer is 7 over 2 or 1. So this third question, in what ways are the questions in A and B similar? Well, they're very similar because they both factored to be the same binomials, the 2D minus 7 times D minus 1. But they're different because in part A, it could only be factored since it was an expression, while in part B, after I factor it, I set each factor equal to 0, and I'm able to solve for the variable D. So they're different because B can be solved, while A can only be factored. I'm not going to write that down since I just said it out loud. Next page. Graph the following function and identify the key features of the graph. So just so you know, you can actually enter this function into your calculator as is. If you wanted to multiply it through, you could. And I will just for the heck of it, just so that I can talk to you about certain things. I would probably multiply the two binomials first to get x squared minus 2x, or actually it's a plus 2x, then a minus 2x minus 4, and this is still being multiplied by the negative 3. So h of x we have a visitor, sorry, hold on.